Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Journey through the history of astronomy. The dawn of observation, gazing at the heavens. Imagine a world bathed in the soft glow of campfires, with the vast expanse of the night sky stretching overhead. For our earliest ancestors, the stars weren't just twinkling decorations. They were a captivating mystery, a source of wonder and a guide for survival. The history of astronomy, the study of celestial objects and phenomena, stretches back to these very beginnings. There are no written records of these first astronomers, but their legacy lives on in the traditions and practices passed down through generations. Early humans relied on the sky for more than just stargazing. By observing the movements of the sun, moon, and stars, they learned to predict the changing seasons, crucial for hunting and gathering. These celestial observations laid the groundwork for the development of calendars, helping people track time and plan agricultural activities. The night sky also served as a giant navigation tool. By recognizing constellations and the positions of specific stars, early travelers could chart their course across land and sea. For example, Polynesian voyagers used their knowledge of the stars to navigate vast distances across the Pacific Ocean. These early observations may seem rudimentary, but they represent the seeds of astronomical curiosity. Our ancestors looked up at the night sky with a sense of wonder, sparking the desire to understand the patterns and movements of celestial objects. This fundamental curiosity is what continues to drive astronomical exploration to this day. Mapping the skies, from naked eye to instruments. As human civilizations developed, so did their methods of celestial observation. No longer content with simply gazing at the stars, early astronomers sought to record and interpret what they saw. Around 3000 BC, the Babylonians in Mesopotamia were among the first to develop detailed star charts, meticulously cataloging constellations and tracking the movements of planets across the night sky. These early charts served as a celestial map, helping people identify and predict the positions of celestial bodies. The Egyptians made significant contributions as well. They aligned their pyramids with specific stars, demonstrating an understanding of celestial movements. Their detailed observations of the night sky helped them develop a sophisticated calendar based on the cycles of the sun and moon. In ancient Greece, astronomy became intertwined with philosophy. Astronomers like Hipparchus of Rhodes compiled star catalogs with unprecedented accuracy and developed methods for predicting eclipses. Hipparchus is also credited with creating the first comprehensive celestial coordinate system, a framework that allowed astronomers to precisely locate objects in the sky. Early astronomical instruments were as ingenious as they were simple. The sundial, a device that uses the sun's shadow to tell time, is one of the earliest examples. Another instrument, the gnomon, was a simple vertical rod used to measure the sun's altitude and track its seasonal changes. These early tools marked a turning point in astronomy, ushering in an era of more precise and systematic observation. The birth of philosophy, questioning the celestial order. Astronomy wasn't just about mapping the night sky. It also sparked philosophical debates about the nature of the universe. In ancient Greece, philosophers like Aristotle proposed models to explain the celestial order. Aristotle's geocentric model, the prevailing view for centuries, placed Earth at the center of the universe with celestial bodies revolving around it in perfect spheres. This model offered a seemingly intuitive explanation for our daily observations. The sun appears to rise and set each day, suggesting Earth is stationary. However, not everyone agreed with Aristotle's model. Aristarchus of Samos, a Greek astronomer from the 3rd century BC, proposed a revolutionary heliocentric model. He argued that the sun, not Earth, was at the center of the universe with Earth and other planets orbiting it. While lacking the technology to definitively prove his theory, Aristarchus's idea challenged the prevailing view and planted the seed for a major astronomical revolution that would take centuries to unfold. His heliocentric model, based on mathematical calculations and observations, laid the groundwork for a new understanding of the cosmos. The Islamic Golden Age, preserving and expanding knowledge. The torch of astronomical knowledge was carried forward during the Islamic Golden Age, a period of scientific and cultural flourishing that stretched from the 8th to the 13th centuries AD. Muslim scholars played a crucial role in not only preserving the works of Greek astronomers but also expanding upon them. They translated ancient Greek texts into Arabic, making them accessible to a wider audience and sparking renewed interest in astronomy. This period witnessed significant advancements in astronomical observation and instrumentation. Al-Battani, a renowned astronomer from the 9th century, was a meticulous observer who made significant contributions to our understanding of planetary movements. He corrected errors in previous star catalogs, developing more accurate methods for calculating planetary positions. His observations of the sun's motion led to the creation of more precise astronomical tables, essential for navigation and calendar making. These tables, incorporating his meticulous observations, were used by astronomers and sailors for centuries to come. Another prominent figure, Al-Biruni, was a polymath with a deep interest in astronomy. He was a keen observer and a critical thinker, not afraid to question established views and conduct his own experiments. Al-Biruni challenged the prevailing belief that the Earth was stationary and proposed the possibility of its rotation, a revolutionary idea for his time. His writings also explored topics like astrolabes, sophisticated instruments used for measuring the positions of celestial objects. These instruments, incorporating gears and intricate scales, allowed for more accurate measurements than their predecessors. The Islamic Golden Age wasn't just about preserving knowledge. It was also a time of innovation. Muslim astronomers developed new instruments like the quadrant, an improvement on the astrolabe, allowing for even more accurate measurements of celestial altitudes. They also made significant contributions to the field of optics, grinding and polishing lenses with a higher degree of precision. These advancements in optics paved the way for the development of telescopes centuries later, laying the groundwork for a new era of astronomical discovery. The Copernican Revolution, a paradigm shift. The 16th century witnessed a dramatic shift in astronomical thought with the work of Nicolaus Copernicus. This Polish astronomer challenged the long-held geocentric model, which placed Earth at the center of the universe, with his heliocentric theory, proposing a sun-centered solar system. Copernicus's ideas were based on years of meticulous observations and mathematical calculations. He noticed inconsistencies in the geocentric model, particularly with regards to planetary motion. For example, the geocentric model required complex epicycles, small circles within larger circles, to explain the observed retrograde motion of planets. Copernicus's heliocentric model offered a more elegant and accurate explanation for these observations, suggesting that planets orbited the Sun in elliptical paths. However, Copernicus's work wasn't readily accepted. His heliocentric theory contradicted the teachings of the Church, which supported the geocentric model based on interpretations of Scripture. Despite facing resistance, Copernicus's ideas sparked a scientific revolution. His work laid the groundwork for future astronomers like Johannes Kepler and Galileo Galilei, who would provide further evidence supporting the heliocentric model. The Copernican Revolution represents a turning point in the history of astronomy. It challenged established beliefs and ushered in a new era of scientific inquiry, placing observation and experimentation at the forefront of astronomical research. The heliocentric model became the foundation for our modern understanding of the solar system, paving the way for further exploration of the cosmos. Unveiling the universe with telescopes, a new era of discovery. The invention of the telescope in the early 17th century revolutionized astronomy. This new instrument provided astronomers with unprecedented power to observe the universe in detail. Galileo Galilei, often called the father of observational astronomy, was among the first to use the telescope for celestial observations. His discoveries transformed our understanding of the cosmos. Galileo turned his telescope towards the night sky and made groundbreaking observations. He discovered the phases of Venus, a phenomenon inexplicable under the geocentric model but predicted by the heliocentric theory. He observed 4 moons orbiting Jupiter, challenging the notion that Earth was the only celestial body with moons. And most strikingly, he observed sunspots on the Sun's surface, discrediting the idea of a perfect and unchanging celestial sphere. Galileo's discoveries not only supported the heliocentric model but also revealed a universe far more complex and dynamic than previously imagined. The telescope opened a new window to the cosmos, allowing astronomers to see celestial objects for the first time with clarity and detail. This new era of telescopic observation laid the foundation for further exploration of the solar system and beyond. It paved the way for astronomers like Johannes Kepler, who used telescopic observations and mathematical calculations to develop his 3 laws of planetary motion. These laws explain the elliptical orbits of planets around the Sun, a key aspect of the heliocentric model. Telescopes also allowed astronomers to discover new celestial objects like nebulae and comets, revealing a universe filled with previously unseen wonders. The invention of the telescope marked a turning point in astronomy. It ushered in an era of scientific discovery based on direct observation, forever changing our view of the universe. With telescopes becoming more powerful, astronomers continued to push the boundaries of our knowledge, paving the way for further exploration of the cosmos. The laws of motion and gravity. The 17th century wasn't just about observing the heavens. It was also a time of profound theoretical breakthroughs. Johannes Kepler, a contemporary of Galileo, made crucial contributions to our understanding of planetary motion. Building upon the meticulous observations of Tycho Brahe, a Danish astronomer who recorded precise planetary positions over decades, Kepler developed his 3 laws of planetary motion. These laws, based on complex mathematical analysis of Brahe's data, explain the elliptical orbits of planets around the Sun. Kepler's laws not only provided strong evidence for the heliocentric model but also laid the foundation for celestial mechanics, the study of the motion of celestial bodies under the influence of gravity. Shortly after Kepler, Isaac Newton revolutionized our understanding of the universe with his law of universal gravitation. This elegant and powerful law proposed that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. Newton's law wasn't just limited to celestial bodies. It applied to all objects, from apples falling from trees to the motion of planets. This universal law explained a wide range of phenomena, from the behavior of comets to the tides on Earth. Newton's work unified the understanding of motion on Earth and in the heavens, providing a single framework for explaining the movements of celestial bodies. Beyond the solar system, exploring the Milky Way and beyond. With the development of more powerful telescopes, astronomers ventured beyond the familiar confines of the solar system. In the 18th century, William Herschel, a German-born astronomer living in England, made a groundbreaking discovery. Using a newly built telescope with a larger mirror than any before, Herschel observed a faint object that didn't follow the expected path of a star. Further observations confirmed it was a planet, significantly expanding the boundaries of our solar system. This newfound planet, Uranus, became the first to be discovered since antiquity. The 20th century brought even more profound discoveries about the universe beyond our solar system. Edwin Hubble, an American astronomer working at the Mount Wilson Observatory, made a groundbreaking observation in 1924. He discovered that certain faint, fuzzy objects previously thought to be nebulae within our Milky Way galaxy were actually entire galaxies themselves, millions of light years away. This discovery shattered the long-held belief that our Milky Way was the only galaxy in existence. Hubble also observed that these distant galaxies were all receding from us, with the most distant galaxies moving away at the fastest rate. This observation led to the concept of an expanding universe, a fundamental shift in our understanding of the cosmos. Hubble's work not only redefined the scale of the universe but also laid the groundwork for the study of cosmology, the study of the origin and large-scale structure of the universe. The tools of modern astronomy, from radio waves to space telescopes. The 20th and 21st centuries have witnessed a revolution in astronomical observation. We are no longer limited to the visible light our eyes can perceive. New technologies like radio telescopes, space telescopes, and advanced detectors have allowed us to explore the universe across the entire electromagnetic spectrum. Radio telescopes, which pick up radio waves emitted by celestial objects, have revealed a universe invisible to our eyes. These groundbreaking instruments have helped us discover a vast array of phenomena, including pulsars, rapidly spinning neutron stars that emit beams of radiation like lighthouses. Radio telescopes have also revealed quasars, incredibly bright objects powered by supermassive black holes at the centers of distant galaxies. These discoveries have challenged our understanding of the universe and forced us to reconsider the physical processes at play in extreme environments. Space telescopes, operating beyond the distorting effects of Earth's atmosphere, provide us with sharper and deeper views of the cosmos. The Hubble Space Telescope, launched in 1990, has revolutionized our understanding of galaxies, stars, and nebulae. Hubble's sharp images have allowed astronomers to study the formation and evolution of galaxies, peer into the atmospheres of distant exoplanets, and witness the birth and death of stars in unprecedented detail. The success of Hubble has paved the way for even more powerful space telescopes like the James Webb Space Telescope, launched in 2021. Webb operates in the infrared spectrum, allowing it to peer further back in time to the earliest stars and galaxies and study the atmospheres of potentially habitable exoplanets. Advancements in detectors have also played a crucial role in modern astronomy. Charge-coupled devices, CCDs, have replaced photographic plates as the primary imaging technology for telescopes, allowing for greater sensitivity and digital manipulation of astronomical data. These advancements have enabled astronomers to capture faint and fleeting phenomena, pushing the boundaries of our observable universe. The quest continues. Astronomy remains a dynamic and ever-evolving field. Today, astronomers are at the forefront of scientific exploration, grappling with some of the universe's most profound mysteries. One such mystery is dark matter and dark energy. Dark matter, an invisible substance thought to make up most of the matter in the universe, exerts a gravitational pull on visible matter but doesn't interact with light. Dark energy, a mysterious force, appears to be accelerating the expansion of the universe. Understanding these enigmatic components of the cosmos remains a major challenge for astronomers. Another area of active research is the search for life beyond Earth. With the discovery of thousands of exoplanets, astronomers are now looking for planets that could potentially harbor life as we know it. They are studying the atmospheres of these exoplanets, searching for biosignatures, chemical signatures that could indicate the presence of life. Missions like the James Webb Space Telescope and future space exploration endeavors play a crucial role in this quest to answer the fundamental question: are we alone in the universe? The quest to understand the universe is a story that continues to unfold. As we develop new technologies and explore the cosmos with ever-increasing sophistication, we continue to unveil the wonders and vastness of our place in the cosmos. From the naked-eye observations of our ancestors to the powerful tools of modern astronomy, the human spirit of curiosity and exploration has driven us to unravel the mysteries of the cosmos. The future of astronomy holds the promise of even more groundbreaking discoveries, forever changing our understanding of the universe and our place within it.